Hi, this is Mrs. Allen, and in this video we will be summarizing the distribution of shapes. The first one we are going to talk about is the symmetric distribution. It has roughly the same shape reflected around the center. An example of a graph that is symmetric here. If we took a mirror and held it right down the middle, we could see that what is on the left is reflected over here on the right. Another example, if we tried to fold this graph in half, we would see that it would match up and be symmetric. The next one we are going to talk about is a skew distribution. It extends farther on one side than on the other. There are two types. Here, the tail of this graph goes towards the right, so we say this graph is skewed to the right. On this graph, the tail heads towards the left, so we say the graph is skewed to the left. Unimodal distribution has a single major hump or mode. So if we looked right here at this top one, we have one hump, so we would have one mode here. And at this one again, one hump, so one mode. Bimodal distributions have two major humps or modes. An example of a graph that looks like that is right here. We have two major humps, and we call this bimodal. Multimodal distributions has more than two major humps or modes. So here in this graph, we have three major humps, so we could consider this multimodal. Now, outliers are values that lie far from the rest of the data. So when graphed, it might look like this. This piece of information right out there all by itself would be an outlier. And in this graph, same thing. This one right here would be an outlier. Now you want to report any other unusual features of the distribution, such as maybe gaps. So here, if we're looking at this graph, you can see at size 10, nobody was a size 10 for the shoe. And you might want to tell that right down here we have very small sizes that might have represented children. This block right here could have been mostly women, and this chunk right here might have been mostly men. So a little bit more information would help us understand this graph a little better. Now the normal bell-shaped curve represents a perfectly symmetric distribution where the mean, median, and mode all line up right here in the middle. If our graph is skewed towards the right, these values down here pull the mean to them. Then you would have your median and mode at the hump. If the data points are skewed towards the left, it pulls the mean along with them, having the median here in the middle and the mode with the major hump. So let's look at some graphs and decide whether we want to use the mean or the median. So summarizing the center of distribution by computing the mean and the median, and we need to know when it is best to use each of these. The mean is the sum of the values divided by the count. It is suitable summary for unimodal and symmetric distributions. So here we have one mode, and it's pretty symmetric, so we would want to go with the mean in this set of data. The median is the middle value. Half of the values are above and half are below the median. It is a better summary when the distribution is skewed or has outliers. So here in this graph, we have it skewed towards the right and an outlier out here. So we would want to go ahead and go with the median. Now we want to compute the standard deviation and the interquartile range and know when it is best to use each summary in the spread. So the standard deviation is roughly the square root of the average squared difference between each data value and the mean. It is the summary of choice of spread if it is unimodal and symmetric. So here since it's symmetric and has a major hump right here in the middle, we would want to go with the standard deviation. The interquartile range is the difference between the quartiles. It is often a better summary of spread if for skewed distributions or data with outliers. So here our graph is skewed towards the right and some outliers out here. So we would want to go with the interquartile range. We'll want to report the median and the interquartile range when the distribution is skewed. If it's symmetric, we'll summarize the distribution with the mean and the standard deviation. Always pair the median with the interquartile range and the mean with the standard deviation. So let's look at some graphs and describe the data. So pause the video and decide if you have a graph that's symmetric, skewed, unimodal, bimodal, multimodal. If you have outliers, list some unusual features, and if you should use the mean and the standard deviation or the median and the interquartile range. Restart the video when you're ready to check your answers. Okay, looking at this graph, we could say that it is skewed towards the left, that it is unimodal. We have one major hump here, and we would want to go with the median and the interquartile range, and we don't have any outliers here. Looking at the next graph, go ahead and pause it and try to answer the questions. Restart it when you're ready to check your answers. In this graph, it's pretty symmetric. It is unimodal. We don't have any really unusual features or outliers, and we could use the mean and the standard deviation. Try to describe this piece of data, and when you're ready to check your answers, restart the video. Here we have a bimodal distribution, two major humps, one around noon and one around 7 p.m. So it's probably customers there for lunch, customers there maybe around dinner time, evening. Looking at the last graph, go ahead and pause the video, try to answer the questions, restart the video when you're ready to check your answers. This graph is skewed towards the right. It is unimodal, and we have an outlier out here. So we would want to go with the median and the interquartile range. Thank you for watching the video. Hopefully it helped you understand summarizing distributions of shapes.